Hello guys, so today I'm going to be making your systems in physics lab. Yay, physics lab. Alright, so how this works is that I'm going to be making your systems. And for some reason I don't know. So like I insert a star and I insert random planets. I have 600 coins. Do not know how I got that. So yeah, I make custom systems like this, for example. Hello Suki and OG Gaming! How's it going for you two? So the closest planet is arid planet. Second closest will be barren planet, ocean planet, continental planet, frozen planet, and deserted planet. Hang on, let me just okay, brother. Okay. 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 I'm back in. It's already 2032. It's 2032. I don't understand. Yeah, hello D Gaming. All right. So let's empty desktop and start making a Suki's system. All right, so let's go. Suki star. Suki star. And then just gonna add a random planet, like arid planets. I know that Suki's planet is arid. Just gonna name that Suki, and then 6.58 megameters, 6.158 megameters, and then the mass it's going to be. So its density is 5.03 grams. The star is named Rekis for my sister. Rekis. Okay. Rekis. Rekis. And Suki might have an elliptical orbit. Hang on, what's her semi-major axis? Suki, what's your semi-major axis? From Rekes. Wait, hold on. see here. 0.1. What in the, excuse you. Excuse you. I think Sugi doesn't have a elliptical orbit, so I'm just going to set it as this from now. Alright, save to disk. Suki's star. No, wait. Rekka's system. Suki J5K. That's nice. Alright. Empty desktop. Next up we have... Okay. Next up is alright, let me just look at YouTube for a sec and see if there is any systems. My system. No. Meet my solar system. Meet my solar system. Okay. My solar system. Okay, bro. Okay. What? Alright. My system. It's just called Meet My System. Alright. Alright, so I'll be choosing random systems. So I'm gonna start with next up is David's Productions. David's Productions system. Alright. Who's No, it's not glitching. No, it's not glitching. It's not glitching. It's not glitching. It is not glitching. Alright. So radius. 0.62 solar. So 0.62 solar radii. And the mass 0.65. So we have to multiply each 3 by 6 and then 5. So wait, hang on. So according to physics lab, the mass of the sun is 333.06 kiloearths. And then multiply that by 0.65. What would we get? 216.489. Alright, so 216.489. Alright. Alright, so Haguia's. Hang on. Heguias dumb. Alright. Hercurium. Alright, so we're gonna add a random planet. Alright, so now we can name this Hercurium. At David's Productions. Alright. I hope no one sees this. I hope no one watches me. Since I want this account to be private for some reason. Alright, so distance to the stars 0.12 AU. Alright. Let's make this 0.12. I do not know what the third one is, but that's okay. Alright. I don't know its eccentricity. I do not know its eccentricity. Let's see here. So, no, that is. So I'm just going to adjust it until it's at like 0% eccentricity. Alright. Now 0.3 Earth masses. Alright, so its radius, the Earth's radius is 6.371. So let's multiply that by 6 and then divide by 10. Now divide all of this by 10. Alright. It's alright. Anyways, goodbye. Alright. Gearthrum. I believe that's a continental planet. Alright, so distance to the sun stars 0.43 AU. No. Alright, I believe that's good. And let's name this Girthrum. Yeah, that's alright. Oh, it froze. Okay. Okay, hang on. Let's try this again. I don't think that life is possible. That's nice. Alright, so what will happen if it's like 43 AU? Oh, wait. It's probably going the range of. Okay, so. Okay. Okay, so when you're at a so according to Physics Lab, when you are at like, when Girthrum is like at 0.43 AU from Heguiasdom, it couldn't sustain life. Since it's 221 Kelvin. Even though if it's already in the 200, 300 Kelvin range. Six Earth masses. Alright, so let's divide each number by 4. So 1. And then multiply each number by 5 to make it 1.25 Earth radii. So 25. Alright, so its density is 4.52 grams. Okay, what about 3.85? 7.6 is, alright, average densities. We won't do moons in this system because, if I try to do a moon for, let's say, Hercium. If I try doing that, then let's make this to 1, 0.1. And I need to. Alright. Let me just go back to my server. I mean, I mean my live stream. Oh my god, now I think that live streams and servers are the same thing.
Hope don't watch up you set this by 10.
Alright, so 3.8266. No wait, 226, not 266. Ah, there we go. Alright. Now, next up we have Davidus. Probably going to do Saturn because it looks like a gaseous planet plus it has rings. Alright. 0.6 AU is the distance. Alright. 1.5 Earth radii. So let's divide each number by half. I mean by 2. Okay. And then just multiply by 3 because right here it says like 1.5 Earth radii, and 1.5 is 3 halves. Let's see here. Alright, next up, Makutia. Wait, hang on. How many? Alright, so. Okay, it has a huge inclination. What in the? Excuse you. I wonder why planets keep getting this weird inclination thingy. Need to be at least 0. Yep. Okay. Alright. I guess we're good. Alright. Alright, we're good. We're good. Alright. Okay, brother. Okay. Alright. Let's rename this to Makutia. The distance from the star is 3 astronomical units. And of course, no one else is in my stream. Alright. "12 Earth masses and 3.75 Earth radii." Alright, so 3.75 is like 15 quarters, so just going to do the same process again. 1. And then what's... Hang on, let me use a calculator since the non-calculator math is so difficult. 23.89125. Big word spell. Alright, so its density is 1.25 grams per centimeter. Alright. Alright, next up. A Jundra. Ooh, 7 AU. That is a lot. Seven. Alright. 4.5 Earths worth of radius. With 25 Earth masses. $28.6695. Alright, so who is more massive? Let's see here. Alright, yep. It is a little bit less dense than Neptune. Redrius. Alright, lastly, Redrius. And okay, brother, okay, I think there is an ejection that is about to happen. I think David have forgot to fix that mistake. Wow. What? Alright, this is good enough. Oh, nope. That, not quite. Alright. I guess this is good enough. "15 Earth masses. With 4 Earth radii. $25.484. Alright, so this is the amazing David system. Alright. Alright. Well, since no one is commenting on my stream, I guess I've decided to end this. Good night, everyone. Oh, shoot. Why are they all the same size as the sun?